Okay. Good morning, children. Welcome to day 4 online class for class 10 students. Chapter 2 sets topic is going on for you. Until yesterday, we have completed the contents which are beginning from the introduction part. See, particularly yesterday, we have seen union of sets, singleton set, difference of sets, next equal sets and equivalent sets. All these definitions yesterday we have completed. So today, hope today will be the last class for the finishing of chapter 2 sets. So today we need to focus on the following topics: number of subsets of a given set, power set. Next, in introduction part, I have told you about finite and infinite sets, because George Cantor he defined about finite and infinite sets. I told you cardinal, ordinal points also I told you. So later, after finishes these two topics, number of subsets of a given set and power set. Next, we need to discuss about finite set and infinite set. Under what conditions the two sets are said to be empty sets or not. And some examples also we will discuss based on those topics. And finally, Venn diagrams. Venn diagrams is nothing but until now we found A union B, A intersection B, or A minus B by using a particular method or particular process. So instead of using that process or a particular formula, we would like to go through the diagrams. We represent them in Venn diagrams. See, let us go through the first one, number of subsets of a given set. If A is the set with n of A is equal to m. That means here there is a set A which is consisting of m elements. Then number of subsets of A are 2 power m. And the number of proper subsets, when we want to find proper subsets, we should subtract 1. What should we subtract from 2 power m means we know the properties of sets while writing subsets. Every set is a subset of itself. Every set is a subset of itself. That condition we should subtract from here, right? Let us consider a set E is equal to set of 1, 4, 9, 16. List all subsets. List all subsets. Here you see, while writing the solution, first of all you write n of E is equal to 1, 2, 3, 4 elements are here. Now, what is the formula to get number of subsets? Number of subsets is equal to 2 power m. 2 power m. M means number of elements. That is 2 power 4. It is nothing but 16. Is it correct or not? 2 power 4. 2 power 4 means 2 2s are 4, 4 2s are 8, 8 2s are 16. So totally 16 subsets we may get for the given set. What are they? Now you see. They are first of all, we are asking to write a null set. We are asking to write a null set because null set is a subset of every set. Here you see actually 4 elements are given. These 4 elements you may separate one element by using a particular set. Set 1, 2, 9, 16 means for each element we use set bracket. And next the combination of two letters 1, 4, 1, 9, 1, 16, 4, 9, 4, 16, 9, 16. See, till now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 subsets are there. Okay. Next, the combination of three letters we must write. 1, 4, 9, 1, 9, 16, 4, 9, 16. You count once. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And one more we left by using the combination of three letters. 1, 4, 9, 1, 9, 16, 4, 9, 16. Still, is there any example do we left? You recognize once. 1, 4, 9, 1, 4, 16, 1, 9, 16, 4, 9, 16, and by using the 2, yes, 1, 4, 16, that's very good. 1, 4, 16 we did not write. And finally, the entire set E, combination of all the elements from this set. Because we know null set is said to be a subset of every set. Every set is said to be a subset of itself. You count once, how many subsets do we get here in this example? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. So first of all, null set you must write. The combination of only single digit numbers we write as 1 sets, 2 numbers as 1 set, 3 numbers as 1 set, and finally the entire set you write. So in the same way we may get the number of subsets for a given set. And if you go through the proper subsets means we must get 2 power m minus 1 means 16 minus 1, 15 subsets only we will get. So what should we eliminate from these 16 means this every set is said to be subset of itself is there, no? That set we should separate, and rest of the first 15 subsets comes under the solution for number of proper subsets while writing. And next definition is a power set, which is related to this only. The set of all subsets of a given set A is called the power set of A, and it is denoted by P of A. That means actually these are all the sets only. These are all the subsets. It means what they are sets only. But all these subsets we don't want to consider as sets. We consider them as an elements. Then such type of set is known as a power set. Here null set is a set, but we consider them as one small element. So 1, 4, 9, 16, 1, 4, 1, 9, and so on. The last one 1, 4, 16 and E. So totally these are 16 subsets are there, no? These 16 subsets we consider here as elements, not sets. Then such type of set is known as a power set. The set of all subsets of a given set A is called the power set of A, and it is denoted by P of A. Here one note we should remember: A has n elements, then power set P of A contains exactly 2 power n elements. That means in a power set how many elements will be present? 2 power n. That means these are all the elements. We don't want to consider them as sets. So here they are subsets. 16 subsets are there. But these 16 subsets we consider as 16 elements in a power set. So is it clear to finding subsets and writing a power set? So okay, note down. Okay, listen, children. Next definition is finite and infinite sets. What is meant by finite set? A set with countable number of elements is a finite set. A set with countable number of elements is a finite set. That means we can count how many elements are present in the set. We are able to say how many elements are present in the set. Let me give an example. Days in a week. Days in a week. How many days are there in a week? How do we know, sir? Can you ask that question? No one supposed to ask that question because we know very well the days, the names of the days. What are they? Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. So these are the 7 days will comes circular process while writing days in a week. So there are 7 days in a week. So that's why this is a set with countable elements. Let me give some examples for finite set. The set of class 10 students in our school. Can we count the number of students in class 10th or not? Even though we have 2 sections or 3 sections, we can count the number of students easily. So the number of students in a particular class is a finite set. How many teachers are working in your school? This is also a finite set. It is accountable. If you go through the staff register, we can count how many teachers are working in our school, isn't it? So that's why finite set means a set with a countable number of elements is a finite set. Example, days in a week. So many examples we may give. Number of days in a month. Let us suppose this is the month of December, we have 31 days. This is the month of June, we have 30 days. This is the month of February, 28 or 29 days, even though if it is a leap year. And next, a set with uncountable number of elements is an infinite set. N is equal to set of all. N is means natural numbers. N is equal to set of all 1, 2, 3 and so on. We don't know how many numbers are possible. They are infinite numbers. So this is infinite set. Here you see one small note that is an empty set of null set phi which has no element, but even though an empty set which is not having any elements in this set, but this we consider as finite set. Why finite set? Because, can you guess any one of you? Why should we say an empty set becomes a finite set? Why we don't want to say it is infinite set? Because we are able to count how many elements are possible in the null set. If you see this, how many elements are present in this set? There are 7 elements who are present in this set. Here null set, if you take how many elements are present here, 0 elements are present. That's why this is a finite set. And next next definition is empty sets. Of course, we might have discussed about empty set or void set or null set in our previous classes. So here some examples will be given, means the combination of 2 sets will be given. By using those combinations, can we able to say whether they are empty sets or finite sets? By giving the examples. It depends on the examples. Sometimes it may given numbers or it may be given a sentence also. Here you see one example. Set of integers which lie between 2 and 3 is an empty set. Someone is saying there is a set. In that set, what elements are present? The elements are present in between 2 and 3, but they are integers. In between 2 and 3, rational numbers are infinite rational numbers are possible. But integers, how many integers are possible? No integer is possible. That's why this is the example for empty set. You see here the set of lines. Second example, the set of lines passing through a point is not empty. Why do we say this? Why do we just this statement is not empty? I wrote clearly, it is not empty. What is the reason? Can you guess, any one of you? Yes, because the set of lines passing through a point, if you represent any point on the surface or blackboard, try to draw some lines. How many lines were passing through this line? There are infinite lines made drawn. So that is the reason this is not an empty set. Did you understand about the finite and finite sets? And by giving some examples through applications, are we able to justify whether they are empty sets or non-empty sets? Did you understand? Okay, note down. Okay, so mostly all the topics has been covered from the sets chapter. Now the last topic is Venn diagrams. See, Venn diagrams are known as Venn Euler diagrams, or simply Venn diagrams. Actually, his full name is John Venn. He and Euler, Euler is also a familiar name to you. So both of them, they might have done work to draw the Venn diagrams. But most probably, Venn only gave most of the valuable suggestions to draw the Venn diagrams. So that's why usually Venn diagrams are known as Euler Venn diagrams, or simply you remember Venn diagrams. See, when Euler or Venn diagrams is a way of representing the relationship between the sets. So, in our 10th class level, what type of Venn diagrams they were asking in the examination point of view, or what should we discuss in our 10th class level, in our 10th class base. So, let us see. I told you previous class, we need to use rectangles to represent universal set. So whatever you draw the diagrams, that the entire diagrams we must represent in a rectangular box. So that rectangular box represents the universal set. Why? Because we know very well every set is said to be a subset of universal set. Yes or no? Say some examples. First one is A is said to be subset of B. Let us draw one rectangle which represents U. That is nothing but universal set. A is said to be subset of B. What does it mean? If all the elements of A are present in the set B, then B is known as superset of A, and A is said to be the subset of B. So thus A is a small circle and B is a big circle. A circle lies inside the B circle. Then this diagram is said to be A subset of B. Next, A union B. This rectangle represents the universal set. This is a set A and this is a set B. In these two diagrams, by A union B means what? We know very well, to combine all the elements from the given sets. So we should shade both the circles. And next, third one is A intersection B. To represent A intersection B, first of all we want to draw a rectangular box which represents an universal set. Let us draw two circles to represent the two sets A and B. A union B means we know to combine the two sets. A intersection B means it is nothing but the common part from the both the circles. Where do we get the common part from the both the circles? Can you identify any one of you here? Can you guess? Yes. And this is the common part where the two circles will be intersected. That part comes under the intersection part for the, that means that is the common part for the both the circles. So let us shade that part only. We need not to shade the rest of the portion. So the part which is common to the both circles only we must shade. Is it clear, Amma? Now fourth one, A minus B Venn diagram. A minus B means we told you according to the definition of while writing the definition of difference of two sets, we have already wrote about set builder form of A minus B also. X says that X belongs to A and X does not belong to B. So let me draw two circles to represent the two different sets A and B. To represent A minus B as Venn diagram, we need to shade the part comes under only A, not in B. If you go through this middle part, this is the common part for both A and B. So except that part, rest of the A circle we must shade. So that comes under the solution part of A minus B. Means, so take care about while drawing the lines. The lines should not meet the common part. So inside this common part, this is the common part for two circles, you know. This is nothing but A intersection B. So the lines should not go inside the common part. So here only we must draw the lines. So this diagram represents A minus B. Now B minus A. So similarly, can you guess how the shape of the diagram for representing B minus A? Any one of you? Oh, right. So we should shade the either A circle or B circle. Which one we have to shade? Right, B circle we have to shade except the common part. Except the common part. Let us suppose this rectangular box indicates a universal set. Here we need to show two circles A and B. So the shaded part we should draw except the intersection part for both the circles, the remaining portion of the B circle. And last one is there is a chance to ask to draw a diagram for A minus B union B minus A. How do we represent? It is nothing but union means what? By combining both. You know the definition. We might have seen some examples, some problems. We gave homework also. We might have done. So based on that concept, are we able to draw the Venn diagram for A minus B union B minus A? Nothing is there. We combine these two. So how do we draw diagrams till now? By using two circles except the first one. Draw the diagram as usual. A circle, B circle. First of all, you draw the diagram only for A minus B. And next you draw the diagram for B minus A. You may use vertical lines also to represent B minus A. If you want to show the difference for A minus B, you may draw by using horizontal lines. If you want to show the difference for B minus A, you may draw vertical lines for B minus A. But you take care while drawing a picture for A minus B union B minus A. The lines should not go inside this common part. You leave like that only the common part. This diagram represents A minus B union B minus A. See, these diagrams are known as Venn Euler diagrams or Venn diagrams. Simply we call it as Venn diagrams. You remember Venn diagrams, it is enough. We need not remember both the names. So we may get confused also, there is a chance. See here today, in our last topic, we have drawn some pictures based on Venn diagrams. That is, A is said to be a subset of B. A union B, intersection of B, A minus B, B minus A minus B union, B minus A. So these are all the variable Venn diagrams in our 10th class level. Did you understand how to draw the diagrams? Okay, note down in your CW. Okay children, please note down the homework for today. That is the last class for the finishing of sets topic. The first one is a list of the subsets of first one. B is equal to set of all P comma Q. C is equal to set of all X comma Y comma Z. D is equal to set of all A, B, C, D. So these are three sets are given by using how to find number of subsets to a given set. We know the formula 2 power n. Yes or no? So by using that formula, find out the number of sets. Simply, I am not asking how many subsets are possible. You must write all the subsets. What are they? That subsets also you must write. Don't use and say, sir, 8 subsets are possible, 10 subsets are possible. I am not asking that answer. I am expecting the complete answer for that first question. See second one. State which of the following sets are empty and which are not. Which are the following questions are empty sets and which are not the non-empty sets. You see, first one, X says that X is a natural number, X is less than 5 and X is greater than 7. There is a number, natural number, that number less than 5, that number must be less than 5, but it must be greater than 7. So like that, can we define any natural number comes under the first set? Can you guess and say, try to find out the answer and then conclude that whether it is empty set or not by writing the solution. Second one, X says that X is a common part of any two parallel lines. Two parallel lines are there. For two parallel lines, there will be a common point. A common point is possible for two given parallel lines or not. If it is possible, you mention that one. Finally, you just whether it is empty set or non-empty set. And third one is a set of even prime numbers. that one also by writing the that value. And finally, the third one is last question is which of the following sets are said to be finite or infinite sets? A. Set of months in a year. B. Set of all 1, 2, 3 and so on 99 and 100. The set is ended with 19, not 99. It is ended with 100. So 1 to 100 numbers are possible in this set. C. The set of lines which are parallel to x-axis. This is a finite set or infinite set. D. The set of letters in the English alphabet. And last one is the set of circles passing through the origin. So observe these 5 examples carefully, and you justice how many of them among these examples comes under finite sets and how many of them are comes under the sets for infinite sets. So in our today's last class we might have discussed about how many subsets, how do we calculate the number of subsets to the given set by using 2 power n formula. If you want to find out the number of proper subsets, I told you 2 power m minus 1 also. And next, the same elements if we consider as an elements, if you are writing a set, that set is known as a power set. And finally, finite set and infinite set. If the set consisting of countable number of elements is known as finite set, if the set consisting of uncountable number of elements is known as infinite set. And by giving some examples based on this second question, are we able to justice whether they are empty sets or non-empty sets? And finally, we discussed about Venn diagrams. So these are the topics today we discussed. So before going to my sincere advice is for mathematics we need a theory part. So simply while doing revision, most of the students what they are doing, simply they try to open their CW or textbook, or else they may open the practice notes and they are trying to do some problems. That is not the way of doing practice. So first of all, we must know the theory part which is related to that particular problems. If we are thorough with that theory part, then we are able to solve the problems easily. Hope, did you understand? So officially for us under day 4, our chapter 2 from maths paper 1, sets chapter have been completed. So is there any doubts? You can clarify for the next class. Try to go through the definitions and focus on more practice from all topics and try to get secure good marks from this chapter also during writing examinations. So but examination is not the criteria, it is not an important role. First of all, try to enjoy to learn with the subject. That is my sincere advice to all students. Thank you for this giving opportunity. Have a nice day to all my dear students. Thank you. Note down the homework.